Welcome to sixth grade math. That was your homework that was due a couple days ago. In 5 days, it snowed 4 inches, 3 inches, 5 inches, 1 inch, and 2 inches. Make a stack of cubes to represent the snowfall each day. So the first one's 4 inches, then 3 inches, 5 inches, 1 inch, and 2 inches. Move the cubes until each stack has the same number of cubes. So I'm going to take one from there, put it there. Take one from that stack, put it in the fourth stack, another from the third stack, and put it in the fourth stack as well. And I left the cubes that I took away from in white, so just so you know that's where they came from. And where I moved them to is in red. So now instead of 4 in the first stack, you have 3. And instead of 1 in the fourth stack, you have 3. On average, how many inches did it snow per day in 5 days? 3 inches, because each stack is now 3 inches, or 3 cubes. Explain your reasoning. What I just said. Suppose on the 6th day it snowed 9 inches. If you move the cubes again, how many cubes would be in each stack? So there's our 3 inches per day, and there are the 9 inches it snowed on the 6th day. So if we start moving a cube to different days, notice when I take one away or turn one of the white ones in the 9 inches, it moves one in red to one of the other stacks. And now we have 4 cubes per day, so it represents 4 inches per day. Mean, also called the average, it is the sum of the set of data divided by the number of pieces of data. So from the mini lab, the data set is 4, 3, 5, 1, and 2, and there are 5 pieces of data. That's before the 6th day of 9 inches. So we have 4 plus 3 plus 5 plus 1 plus 2 divided by 5. So the 4, 3, 5, 1, 2 are the number of inches each day, and the 5 is the number of days. And that's going to equal 15 over 5, or 15 divided by 5, which equals 3. Mean equals average, so they mean the same thing. Find the mean. Find the mean number of representatives for the 4 states shown in the pictograph. So we have Tennessee, Kentucky, Virginia, and South Carolina. Move the figures to equally distribute the total number of representatives among the 4 states. So if we take that away and add one there, then we take one away from Virginia and add another to Kentucky. Then we'll take another one away from Virginia and add it to South Carolina, and another one away from Virginia and add it to South Carolina. Write and simplify an expression. So if we take the original numbers of 9 for Tennessee, 6 for Kentucky, 11 for Virginia, and 6 for South Carolina, and we divide it by 4, it's going to be 32 over 4, or an average of 8. Scaffolding questions. Mean versus median. Median is the middle number of a data set. So if we have a set 1, 2, 3, 4, 5, what is the middle number in a data set? So there are 5 numbers, so the middle number is 3. What is the mean in the data set? So the mean is also known as the average. So if we add the numbers up, 1, 2, 3, 4, 5, and divide them by 5, we get 15 over 5, and that is divided out to 3. Is the mean the same as a median in this data set? Yes, it is. So let's look at another data set, 1, 4, 7, 8, 10. What is the middle number in the data set? So the middle number is 7 because there are 5 numbers and 7 is the third number in, and that is the median. And what is the mean in the data set? Well, if we add up the 1, 4, 7, 8, and 10 and divide it by 5, the number of numbers there are, that's going to equal 30 over 5, or 6. So the mean is 6 and the median is 7. Is the mean the same as a median in this data set? No. Why is this set different? The numbers are different, so the mean and median are different. So it was just coincidence in the first data set on this slide that the mean and median were the same. In the second set, which is more likely to happen, the mean and median are not the same. And central tendency is the center of the distribution of the data set. And the mean is the most common measurement of central tendency. Other measures are mode and median. Choose your method. The bar graph shows the number of CDs bought by a group of friends. Find the mean number of CDs bought by the group. So if we look at the bar graph, Diego has 3, Emma 4, Huey 6, and Tanya 2, and Michael has 0. So if we add those all up and divide them by 5, we get 15 over 5, which is equal to 3. Even if a data value is 0, it should be counted in the total number of pieces of data. And the outlier, values that are much higher or lower than others in the data set. So you could argue 0 might be an outlier here. We're going to look at a more likely scenario with an outlier, and we're going to determine how outliers affect mean. So the number of minutes Marianne spent talking on the phone each month for the past 5 months were 494, 502, 486, 690, and 478. Identify the outliers for the data and find the mean with and without the outlier. Then describe the effects on the mean. So we're going to look at, compare the other values. 690 is extremely high, so I hope you see that. It's about 200 higher than the next closest one. So it is an outlier. And find the mean with and without the outlier. With the outlier, if we add them all up, and notice that 690 is included in there, and we divide it by 5, the number of pieces of data, we'll get 2,650 divided by 5, or 530. Now, if we take the outlier out, we also have to take that piece of data out. So we'll take the 690 out, and we'll change the pieces of data from 5 to 4, and we'll get 1,960 divided by 4, and we get 490. With the outlier, the mean is greater than all but one of the data values. Without it, the mean better represents the data. So what that means is if you look at the 530 when we're using the outlier, that is higher. It says all but one, but the only one that's not higher than is the outlier. The highest non-outlier value is 502, and 530 is higher than that. So notice that the 490 falls in line, falls in between most of the data, so that is more accurate. Identify the outlier and these costs. So we have 110, 120, 110, 135, 140, 120, 105, and 440. Compared to the other values, 440 is extremely high. It's at least 3 times higher than the next highest one. So it is an outlier. Find the mean with and without the outlier. So with the outlier, if we simply add up all those data values up above and divide it by 8, we'll get $160. And without outlier, if we take out the 440 and divide by the 7 remaining data values, we'll get 840 divided by 7, or 105. Now, I hope you notice that the difference, 160, is higher than every other piece of data with the outlier, except for the outlier itself. So that outlier really skewed the mean. And if you look at when we take the outlier out, the 105 lies somewhere in the middle of all of the remaining data. Additional examples. The picture graph shows the current number of electoral votes for selected states. Find the mean number of electoral votes for these 4 states. So we have 11, 8, 13, and 8. So if we add those up and divide by 4, we'll get 40 over 4, which means our mean is 10. Identify the outliers in the data, then find the mean with and without the outlier. Describe how the outlier affects the mean of the data. So here's our data, points per game. With the outlier, we'll add all those up from that table and divide it by 12. And we get 1,050 divided by 12. 87.5 points per game. Without the outlier, if we add it all up, we get 91.5 points per game. So in this case, the outlier is a low number, which is 44, which drops our average points per game down 4 points. Larry Legend. Here's your homework tonight. Head on over to Google Classroom to enter it. Thank you. Have a great night.